sulfuric acid of concentration 6 mole per cubic decimeter from a flask on the laboratory bench. Her teacher tells her to neutralize the spilled acid by sprinkling sodium hydrogen carbonate powder onto it. The reaction that takes place is assume that the sodium hydroxide ionizes completely. The fizzing due to the formation of carbon dioxide stops after the learner has added 27 grams of sodium hydroxide carbonate to the spilled acid. Calculate the volume of sulfuric acid that spilled. Assume that all the sodium hydrogen carbonate reacts with all the acid. The learner now dilutes some of the 6 mole per cubic decimeter sulfuric acid solution in the flask to 0.1 mole per cubic decimeter. Calculate the volume of the 6 mole per cubic decimeter sulfuric acid solution needed to prepare 1 cubic decimeter of the dilute acid. During a titration, 25 cubic centimeter of the 0.1 mole per cubic decimeter sulfuric acid solution is added to an Erlenmeyer flask and titrated with a 0.3 sodium hydroxide solution. The learner uses bromomethyl blue as indicator. What is the purpose of this indicator? Calculate the pH of the solution in the flask after the addition of 30 cubic centimeter of sodium hydroxide. The endpoint of the titration is not yet reached at this point.
Right. Thank you so much, Osin. Yes. So here they say Elena accidentally spills some sulfuric acid of concentration 6 mole per cubic decimeter from a flask on the laboratory bench. Her teacher tells her to neutralize the spilled acid by sprinkling sodium hydrogen carbonate powder onto it. The reaction that takes place is given as follows, under the assumption that sulfuric acid ionizes completely. So we have 1 mole of sulfuric acid reacting with 2 moles of sodium bicarbonate in order to produce 1 mole of sodium sulfate, 2 moles of water, and 2 moles of carbon dioxide. All right. The fizzing due to the formation of carbon dioxide stops after the learner has added 27 grams of sodium hydrogen carbonate to the spilled acid. So what is this fizzing actually? Well, it's just like when you open your carbonated soft drink, those bubbles that form. Yeah, it's something like that. So when when that fizzing stops, it indicates that the reaction between sulfuric acid and sodium bicarbonate has actually reached completion. After the learner has added 27 grams of sodium hydrogen carbonate to this spilled acid. So now the first question is asking us to please calculate the volume of the sulfuric acid that spilled. Assume that all the sodium hydrogen carbonate reacts with all the acid. In other words, we don't have a limiting reagent. We also don't have an excess reagent in this case. So what I want you to realize is in order for you to find the volume of sulfuric acid, all that you need is the number of moles. Why? Because the concentration is already given to you. So then, how can we find the number of moles of sulfuric acid? Well, by means of the stoichiometric calculations. We are given the mass of sodium bicarbonate, so we just need to convert this mass to the number of moles. And then we relate sulfuric acid and sodium carbonate according to their ratio, which is 1:2, and then we are fine. So that's all that we need to do. So as we said, we want to begin by finding the number of moles of sodium hydrogen carbonate because we are given the mass. So we can just use the formula that says you take the mass and you divide it with the molar mass. Well, oh, it's on the document. Yes, the mass is 27 grams. Now, what about the molar mass? Well, I'm just going to press this into my calculator. The molar mass of sodium is 23, hydrogen is 1, carbon is 12. We have 3 oxygen atoms, each with a molar mass of 16. So the molar mass of the entire compound becomes 84. And if we now go to our calculator and find the ratio between 27 and 84, well, we simply get 0.3214. Well, I'm just going to write all of it anyway, because it's not the final answer. So we have 14285,714, and then we say moles. So these are the number of moles for sodium bicarbonate. But according to this balanced chemical reaction, we know that the relationship between sulfuric acid and sodium bicarbonate is 1:2. So what does this relationship actually mean? It means that if I have 0.3214, 2857, 14 moles of sodium hydrogen carbonate, how many moles do I need for the acid? Well, I simply say this one divided by that one multiplied by that one. So I just divide this by 2. That's what I need. So then this means that the number of moles of the acid will simply be 0.16071 4285.7. Then we say moles. So now we know the moles. We also know the volume. In fact, the concentration, I mean. Then it's very easy to find the volume of the acid by using the definition of concentration, of course. Then we say, well, the concentration of the acid is defined as the number of moles divided by the volume. So we are given that the concentration is 6 mole per cubic decimeter. The number of moles, we determined them to be what I'm writing here. And now we just need to find the volume. So if you want to make your denominator to become the subject of the formula, you just take it and make it the subject. And you take what was the subject and you make it the denominator. In other words, you simply divide this entire thing by 6. And you find that the volume will be 0.027. But since you are dealing with 2 decimal places, then it means the volume is going to be 0.03 cubic decimeters. 30 cubic centimeters. That is the volume of the acid. Okay. Next, they say to us, the learner now dilutes some of the 6 mol per cubic decimeter sulfuric acid solution in the flask to 0.1 mol per cubic decimeter. And the key word here is the learner dilutes. And you remember that during a dilution, what is changing is the concentration and the volume, but the number of moles, they remain the same. Now they say to us, calculate the volume of the 6 mol per cubic decimeter sulfuric acid solution that is needed to prepare 1 cubic decimeter of the dilute acid. What is this question saying? Well, the question says, what was the initial volume so that the final volume is 1 cubic decimeters, given that we diluted the initial solution? So that's what they are saying. But one thing we know and understand is the fact that we are dealing with a dilution problem. And we know that every time we dilute an acid or a base, the number of moles, they do not change. The initial moles equals the final moles. And you're allowed to skip this step, honestly, and just define your moles as the initial concentration times the initial volume equals the final concentration times the final volume. We know that the final volume will be 1 mol per cubic decimeter. Sorry, how can the volume be 1 mol per cubic decimeter? I wanted to say the volume, the final volume is 1 cubic decimeter. And the final concentration is 0.1 mol per cubic decimeter. So what we need to know here is what was the initial volume so that the final solution will have that. That's what the question is asking from you. No wonder it's 2 marks. So you just go ahead and say, well, 0.1 times 1 divided by 6. And you find that, well, the initial volume was actually 0.02. It's 0.016666 up until 7. But of course, if we must take it to 2 decimal places, then it's simply going to be this much. Very, very important. During a dilution, the moles, they remain the same. So let's talk. Now here they say, during a titration, 25 cubic centimeters of the 0.1 mole per cubic decimeter sulfuric acid solution is added in an Erlenmeyer flask and titrated with a 0.1 mole per cubic decimeter solution of sodium hydroxide. Have we ever talked about sodium hydroxide ever since we began? Well, that's a big no. So it tells you that this question is independent of everything that happened here. It's a brand new question which has been stored in a cool, dry place. So it's a new question. Yes, they tell us that this volume with this concentration of the acid is titrated with this concentration of this base. So we can see that it's the reaction between a strong acid and a weak base, which is the same as the question that we had before. We were titrating a strong acid with a strong base. Oh, it was still sodium hydroxide and sulfuric acid, even in the previous question. Yes, it was. So what am I trying to say? I'm not sure. But let's move. The learner uses bromothymol blue as an indicator. And they say, what is the purpose of an indicator? That's what they're actually asking. Does anyone have any idea of the purpose of an indicator? Why do we need an indicator in an acid-base reaction anyway? You can just turn on your microphone and tell us if you know it. So no one knows the purpose of an indicator. It is to indicate the end point of a titration. Because we know that the moment you see a change in color, you must stop titrating. So yes, it indicates the end point of the titration. All right. Now they say, calculate the pH of the solution, not the pH of sulfuric acid. That's how it differs to the previous question. Calculate the pH of the solution in the Erlenmeyer flask, because we know that in the Erlenmeyer flask, we have two reactants, sulfuric acid and sodium hydroxide. After the addition of 30 cubic centimeters of sodium hydroxide, and here they say the end point of the titration is not yet reached at this point. Okay. So this question, we are not going to approach it as how we approached the previous one, because the previous one was only looking for the pH of a reactant, which is the sulfuric acid. But here we need to find the pH of the solution. And what I told you is the pH of the solution depends on which reactant is in excess. That's the most important thing. You need to identify the excess reagent. And in the previous question that we did on the pH, the information that was given to us was not enough to enable us to find the limiting reagent of those two. That's why it didn't say find the pH of the solution. It just said for hydrochloric acid. But for this one, they gave us everything that we need in order to find the pH. For instance, or rather the limiting reagent, that's what I wanted to say. They gave you the volume and the concentration of the acid. You can use that to find the number of moles. They gave you the concentration and the volume of the base. You can use that to convert it to the number of moles. So you can find the moles for both of your reactants and then find the limiting reagent, all right? Well, actually, you need to find the excess reagent, but it doesn't matter because if you know that one of them is the limiting, then the other becomes the excess. Okay. If I spoke too fast, then you can always ask me a question after we destroy it. So first things first, we need to calculate the number of moles. The number of moles that were available at the start of the reaction. Very important. But before that, I would really like us to write down the balanced chemical reaction because we are going to need it. So we have sulfuric acid. We don't need to show the states, the phases, that's what I mean. Is reacting with sodium hydroxide, yes? And every time we have an acid reacting with a base, we know that a salt will be formed. And the salt is sodium sulfate. And we know that water will be formed as well. But in order to keep this equation balanced, we now have 2 atoms of sodium on the right. So we have to put a 2 here. Yes? What about the hydrogen atoms? We have 4 on the left. So we need to have 4 on the right as well. The sulfate ions are balanced. The oxygen atoms, we have 2 on the left and 2 on the right. So the equation is balanced. Now we can forget about the balanced equation and focus on what? On finding the initial number of moles, all right? Those that we had at the start of the reaction. So we define the concentration of sulfuric acid. It's defined as the number of moles divided by the volume. And I'm specifying because I'm dealing with 2 substances in the same question. Don't just say C equals N over V. The marker doesn't know it's for who. So always specify. A scientist is very specific. Okay? Well, we know that the concentration is 0.1. We are looking for the number of moles. The volume of the acid is given to us as 25 cubic centimeters. That's a red flag, so we need to convert this to cubic decimeters by dividing with 1,000, in which case we get 0.025. And now it's time for us to cross multiply, and we get the number of moles that are available at the start of the reaction. So we find that, well, these moles will simply be 0.0025 moles. All right. Now we find the number of moles for sodium hydroxide. But once again, we need to define the concentration of sodium hydroxide. And we understand that it's defined as the number of moles divided by the volume. And what they tell us here is they have the same concentration. That is nice. But the volumes are not the same. The volume of the base is given to us as 30 cubic centimeters, which if we convert to cubic decimeters by dividing with 1,000, we simply get 0.03. And when we cross multiply, we find that the number of moles for sodium hydroxide will just be 0.03, right? I'm adding this additional 0 because it's very important when you make your comparison. Don't be tempted to round this one off and say it's 0.03. Hey, you're going to die. A terrible death for that matter. Because then if you do that, well, the number of moles are the same, so there won't be an excess reagent. So don't round off anything. Now what? Now we need to determine how much of one of the reactants do we need in order to react with the other reactant, because we are at that stage of identifying the limiting reagent. So let's say maybe how much of sulfuric acid is actually needed, all right? Let's try to find that out. How do we find that? By looking at the mole ratio. The ratio between sulfuric acid and sodium hydroxide is 1:2. So now we want to know if I have 0.003 moles of sodium hydroxide, then how many moles of the acid do I need? I actually need 0.03 divided by 2, because it's this one divided by that one multiplied by that one. So then the number of moles of sulfuric acid that are needed in order to react with sodium hydroxide are simply 0.0015 moles. Then now it's time for us to make a comparison. Well, what we can see here, we need to compare the moles. Well, here I won't specify, but when you write, please do specify. Or maybe I can go to the next page. What is wrong with me anyway? Well, I'm not sure if it's gonna fit, but we can always try. So we want to compare the number of moles of sulfuric acid that were available at the start versus the number of moles that are needed in order to react with sodium hydroxide. How do they compare? Well, I need 0.0015. This is what I need. But how much do I have? I have 0.025. So we can see very much clearly that what I have is more than what I need, which means that the number of moles of, not really, it means that the sulfuric acid is excess reagent. Okay, We needed the excess reagent, not really the limiting. So now we know the moles that are needed. We know those that are available. Then we can find the moles in excess. So the moles in excess are equal to those that are available at the start minus those that reacted with sodium hydroxide. And when we find the difference between these two, we find that the number of moles that are in excess is going to be this. These are the moles that determine the final pH, the pH of the final solution. There has to be something that is in excess. It can be an acid or it can be a base. But remember, if we found that the number of moles of the base are in excess, then it means we were going to have to calculate pOH first. And then use the fact that pOH plus the pH equals 14. So, but here we'll be getting straight to the pH because we can see that what is in excess is the acid. But you don't need to stress. Tomorrow we are going to deal, in fact, on Monday, we are going to deal with a situation that requires us to find pOH first and then go to the pH. Okay. Now we know the excess moles, then we need to know the concentration of these excess moles. The excess concentration, which is what we found in the previous two questions, those that were for 8 marks. So now, well, we say the concentration of the acid, which is in excess, of course, is still equal to the number of moles divided by the volume. And I want you to pay attention here. The volume that you're going to use is not the volume of the acid. It is the volume of the solution. And the solution here is sulfuric acid and what? And sodium hydroxide. Which means that we need to add those two volumes up. 0.025 plus 0.03. And after we add these two volumes up, this is what we get. Always, that's the volume of the solution. Then we can see that, well, the concentration will just be 0.18. Actually, it's 0.1818. So these 1/8 are recurring mole per cubic decimeter. But this is the concentration of the acid. We don't need that. Well, we do actually. But what we actually need is the concentration of the hydronium ions. And we know that sulfuric acid is a diprotic acid, which means that the concentration of the hydronium ions will be twice as much the concentration of the acid. Please tell them this. And then you can now say, well, I'm going to use all the decimal places into my calculator, as I should, because this is not the final answer. So when I times this by 2, I get 0.025. 0.3636, and it's also recurring mole per cubic decimeter. Then I know that the pH is the negative logarithm of the concentration of the hydronium ions. So it's the negative log of this answer. So when you find the negative logarithm, you find that the pH of the solution will be 1.44. Very, very important.